Everybody. So in this video, I'm going to share all the modules that you have to know for preparation before the competition. So the first module is module 3. It is on basic engineering design and material selection. So what is engineering design process? So it is a series of steps engineers follow to solve problems. So in order to do a proper design in engineering, you have to ask in order to identify the problem, you have to brainstorm the solution, you have to plan, create, test, and finally improve the design. So why it is important? It's because it helps to solve real world problems, and it makes life better with new inventions. So let's go through the 6 main steps for the engineering design process. So the first step is to define the problem. So we have to understand what needs to be solved. So the questions that we need to ask ourselves are: the first thing is, what is the problem? Who has the problem? And why is it important? So in our case, so the problem is there is a lack of uh, there is a lack of used cooking oil collection, making it very difficult for the community to recycle our used cooking oil. So we come up with a solution by making an oil collector um, vending machine. So who has the problem? It's the community. And why is it important? Because we want to recycle oil for the environment. So that is our goal, to help with oil recycling. And then step 2 is to research and gather information. So we have done this. So after we do some research, we have found out that we can make um, a vending machine for the oil collection system to be automated. Now, step 3 is to brainstorm and choose the best idea. So we also have done this process whereby we discuss what will be our solution, and and in order for us to do this, we usually do a decision matrix whereby we see all aspects such as the cost, durability, the ease of construction, and and we use this to choose which design or which proposal that we want to pick. So each category, usually we rate it from 1 to 10, and we take an average to get the total score. But this is just uh, an estimation value. We usually don't choose this only based on total score, but we choose based on our needs. So, for example, if our priority is the cost, then maybe we need to choose this first option. But if um if we have, for example, very limited time and we need to have it to be easy to construct, then we have to use the third option here. So that is just based on our priority. So which is better? If we have many options, then we can do a decision matrix, and we have to do a group discussion to discuss which one works well for you to have a collaborative thinking. This is just an example. So you can do it for your design, but basically you don't have to do this because it's already picked. Our design is already picked, which is the one that you have done your prototype. And now, yes, so step 4 is to develop and build a prototype after you have discussed and choose what is your final design. So you have to use cardboard, some glue, maybe 3D models to build your prototype. So there is a difference between a model and a prototype. So a model is a representation of an object or idea that is used to visualize your product. And this is the example this is the one that I ask you to do, which is the prototype using the cardboard. It is just a basic idea just for you to decide what is your dimension, what is your design before doing the actual prototype. And your actual prototype is a working version, but not in full scale, but in smaller scale of your final product. But it should work as if it is a real product. And all of the dimensions should be um, accurate, meaning that if you scale it up, then it will be suitable for larger scale. Okay. Now, after you have done your prototype, the next thing that you have to do is you have to try it. So does it work? This thing, does it work? For our case, it covers two systems, which are the IoT system and the prototype itself in terms of its strength or in terms of its ease of use. For example, do you have any access to the accept and reject tank? And do you have any slot for you to fill up to pour the oil? And are the buttons accessible? Or the LCD can be seen clearly? So that is the meaning of the aspects that we have to see to know does the prototype work or not. And is it safe and cost effective? And finally, the most important thing is that we have to consider that can it be better? How can we make it better than our original design? So in step 6, the most important step is to make improvements. So we do our tests and make improvement based on our results. So we redesign it until it's the best that it can be. Okay. Next is material selection. So for our current prototype, we have selected straw board, which is made up from a plastic. So maybe you have to prepare like one page of proposed material selection for actual product of the vending machine. So please study what is the common materials that is used for um for actual vending machine, and maybe you can do a sketch and label this part is what material, this part is what material, for the judges to be able to see what is your um proposal if this machine is the vending machine will be scaled up, because now it's only a prototype. Our material selection, of course, will just be a plain plastic because we want it to be easy to be constructed. But in real case, we want it to be safe and sturdy for the use of the community. So material selection matters because it affects the performance, durability, the cost, the sustainability and environment, and safety. So please don't forget to make like one page of drawing that specify what material that you choose for your actual vending machine. So this is the real world examples. For example, if you want to choose the best material for the school chair, so you will have a few options like wood, plastic, and metal. And you should be able to list down what is the pro and cons of each. And then um, the final choice will be depending on the requirement. So some are made from plastic because it's the cheapest, but some invested in wood because it is more durable, even though it is more expensive. So it depends on our situation. Okay, this is a material water bottle. I think I will skip this part. Okay, key lesson. For this module, you learn that different materials have different pro and cons. So the best material depends on how it will be used. So when you select one material, you must know what does it offers and what are the advantages of it. And that will that you have to decide which material is the most suitable. Okay, so next we that is all for module 3. Now we will continue with module 4. Module 4 is on the fabrication techniques and testing of the prototype. So what is fabrication? Fabrication in simple words is just making something from raw materials. So you making the prototype is called fabrication. In engineering, it's just a fancy word for making something. In engineering, it is the process of turning ideas or sketches into real models or prototype. So, fabrication methods involves cutting, joining, or 3D printing and molding. And you have done this during the development of your prototype, so you should already know. Now, the most important thing in this module is for you to know on how to test your prototype and why. So we have to test our prototype after we fabricate it to check if it works as we plan it. And we want to ensure it is strong, safe, and effective. And the key questions, but this is not limited to these questions only, these are just examples. So the first question is, does it break easily? Is it stable and balanced? And can it do what it is supposed to do? So for our case, we want it to receive the used cooking oil from customer and then detects if it is contaminated with water or not, and then pump it to the accept and reject. And it is also supposed to monitor the level of the accept and reject tank and notify the co-op if the level is high. So all of these questions need to be answered by doing tests. So for example, if we are doing a bridge design, then of course it has to withstand some certain amount of weight. So we do load testing to make sure that it can withstand the amount of weight that we target. If we do a design of airplanes, then we do wind tunnel and stress tests. If we design a car, then we have to do crash tests. So this is an example of prototype testing worksheet. You should do this for your prototype. So you have to list down what is the purpose of your prototype. We have you have certain purpose right now. So the first thing will be detecting water contamination and accept or reject it. So that is the first purpose. And then I think the second one will be the level sensor. So you should do testing for each of the purpose of your prototype. If you have two, then you have two tests. But if but since there is not enough time, maybe you can only do one, which is on the water detection. So in our previous meeting, at your school, I have listed like a drafted a table for you to do a testing on the percentage of water that the machine can detect. So you can list here. So if you do that test, then the purpose you can list here. The purpose of your prototype is to detect contaminants, water contaminants from the uh, dispense mm, or use cooking oil. So what material did you use? This is maybe you can list down all the sensors, all the pipings and pumps because this involves the IoT system. And then you can do a testing log. Um, on if you do only one test, then you only have one. So you will have a table and you have to list down what is the results. And you have to mention if it's pass or fail. Um, passing or pass or fail depend on your definition. For example, maybe your machine cannot detect water at very low concentration. Maybe it can only detect water at 5%. At 4%, the machine will not detect it because of the lower sensitivity of the sensor. We will define it as pass or fail depending on um, our definition. So if, for example, if I declare that our machine can only detect 5% of water and it will reject. So if your machine can handle 5%, it means that it will pass. Okay, so this pass or fail depending on what you declare your machine can do or cannot do. Okay, not simply saying that if it does not detect 3%, it is directly fail, but we just have to declare that our machine can only detect 5%. If it's lower than 5%, then you cannot detect it. So if our test reflects what we are saying, means that the test has passed. Okay. And then you can also answer these questions for you to reflect on your test results. And for example, the most important thing is if there is something that is not working, then you have to discuss or suggest that some ways to improve it. So you can ask among yourselves what worked well, what failed or broke, and what can be improved. All of these doesn't necessarily has to be done before the competition. If something is not working well, then you have to just write in write in your logbook and then propose your solutions. Okay. This in engineering, everything is a process. It's not necessarily we have it perfect at the first time. Okay. So, as a wrap up, so building is fun, but testing makes it better. So after you build a prototype, please make sure you have a test, at least one test to test if your prototype is performing well and to know what improvement that you can make for the future. Because engineers always test and improve designs. And your next challenge, if not during this competition, maybe in the next competition, you have to design a better version of what you have done here. Okay, so that is all for module 4. Let's go to module number 5.